Hello, this is Pat with Yankee Mold Incorporated, and today I thought that we could have some fun and just look at the EDM and how to cut a thread. It's not often that I get to just cut threads like a normal person would, but right now we're just tapping in the EDM, and we're going to be tapping some full hard steel, and I just thought that it would be kind of interesting if we just showed how that was done. Now, number one, the first thing we do is we have to bust out the old Machinery's Handbook. Number 27 here is the one I have in the large print, which is easiest to see. And if you'd come on around to my shoulder, I really appreciate it. Now, first thing is that we need to make a 3/8 tap, 3/8 16. And that is right here, 3/8 16. 2B is going to be the tolerances that we're going to be making this to. And that's 307, 321, etc., etc., etc. Now, the old thumb rule for tapping is the diameter minus the pitch is going to yield the tap drill. So 3/8 minus 1/16 is 5/16, or 0.3125. Now that's going to be pretty close to the tap size, and it's really not too far off of the 307, 321 size range here. So that's what we're going to go with, is 3215, or 3125, excuse me, 5/16. So if you take a micrometer and you make up your electrodes, they're going to be real close to 3125. Now, if you look at these threads, they're 266 diameter, 0.266. On the pitch diameter is measured with this thread gauge. Now, a thread gauge is not really the best because of you end up with some error in here, and so you're better off with wires, and I'm going to show both. So that's how you do it with a thread mic. And 366, or excuse me, 0.266, and we want to go out to a diameter of 0.340 being high limit. So if you take that and you take 340 minus the 266 is 3470, roughly 35 thousandths of an inch. And that's really not a bad place to start, 0.035 per side. So if we were to drop this down in and orbit it out 0.35 on a side, we're going to be really close on our OD. How do we make these? Well, again, I've cut the OD down to within 5 thousandths of an inch, so about 317. And then I take and cut the rest of it down with the, now as you can see, I've cut this 317, and then the threads here are 312.5. So I'm pretty confident that these threads are out full size. Now, a little bit about material. One thing about this is that these are cut in carbon, and carbon never throws a burr, and that's why I love it for threads. If you make them out of copper or any sort of metal, you have the potential of having a burr and having a problem with it. Best to just make them out of carbon and never have a burr. Now, while we're on the subject, I did want to talk a little bit about wires. Now, these wires here are supposed to be 036-1. Now, a little bit about a thread, about micrometers here. As you can see, I've been measuring around 300, and I need to get down to 36. One of the slickest ways to do it is just to take the micrometer and run it up here on our sleeve like this and turn it. until you get close. Now there's 50 thousandths. You then slip your little finger through here, your ring finger goes onto the Glock nut, and these two fingers here turn the top of it. This way you've got control of the mic, you can move anything you want on it. Now a word about the 036. Always, always, always measure your pins first just to make sure you grab the right ones. These three are all the same size. They're all 36 and a little bit, or 36 and 1/10. And that's as close as I can measure them. And close enough to know that they're 036. Now, it's difficult always to measure. You will eventually be able to have all three wires in the thread and measure with it. And these end up being about 318 on the micrometer. At any rate, 318 and 5/10 is the number I come up with here. So if we take 318.5 and subtract the 054 off of it, we should come up with the number real close to the 260. So let's see how close we come. I gotta find a calculator here and then we'll be it. So 264.5 over thread wires. Now what happens is that as you make the electrode, your helix angle gets really, really steep as you make them. And this always throws your micrometer off a little bit. So any measuring you do is always going to be slightly in error on these because they just have too fast of a helix angle. If you look at this electrode, you can see it. Now, as it turns out, the old as it turns out, but as it turns out, it's self-compensating because as you mill a helix angle that's too steep, your thread opens up a little bit, and when you cut it when the EDM, it ends up closing a little bit and ends up quote unquote back right. So 264.5 so let's take it minus 0.340 and then divide that by 2 and then get rid of the negative symbol. And that should be your side overburns, 037.8. And that's per side overburn on this electrode should yield pretty close to high limit on the part. Now I've learned over time to always make these slightly close to high limit on these because of the nature of the wear in the EDM. They never end up wearing bigger. They always end up wearing smaller. Odd how that works.